Hello everyone and welcome to the final lesson from chapter 5. This is lesson 5.2.4. What if systems are not in y equals mx plus b form? This is the peak of 8th grade math. This is the climax of the literature story that we are currently in. This is a really hard lesson because you are putting together every single skill that we have done so far this year all together in this lesson. And so we're going to go through a lot of this. I don't expect you to be able to do this on your own yet. We're going to take the next couple of months and we're going to practice this over and over and over until you can do this on your own. So we're going to go through these problems. I believe we have 2 or 3 problems that we're going to go through today, and we are going to look at the system. We're going to decide what to do. We're going to go through step 1, make them equal. Step 2, solve for x. And step 3, go back and check for y. These are the 3 steps when we're solving a system algebraically. So here we go. Step 1. Read the problem. Sarah has agreed to help with her younger sister's science fair experiment. Her sister planted string beans in 2 pots. She's using a different fertilizer in each pot to see which one will grow the tallest. Currently, plant A is 4 inches tall and grows 2/3 inch per day. That's the rule right there. In our problem, that gives us plant A rule. While plant B is 9 inches tall and grows 1/2 inch per day. That is plant B's rule. If the plants continue to grow at these rates, how many days will it take the 2 plants to be the same height? Notice we're in inches. Which plant will be the tallest in 6 weeks? I'm going to ignore that question. Write a system of equations and solve. Remember, yesterday's question, when will they be the same? That is the key question here in this chapter. When will they be the same? So I want you to notice in problem 5-52, you've kind of got a section of paper, and I want you to think of it in 2 parts. Okay? Notice that we're going to deal with plant A and B here on one side, and we are going to, first of all, we are going to solve for x on this side, and on this side we're going to check for y. Okay? Step 1, make them equal. So when I was reading this, I read that plant A grows 2/3 inch per day. We can see that right here. It grows 2/3 inch per day and starts at 4 inches, while plant B is 9 inches tall and grows 1/2 inch per day. Okay? When we want to know when 2 things are the same, we set them equal to one another. Now, the most difficult thing about these 2 problems that we're going to do today is called a fraction buster. If you remember back a couple lessons, we did fraction busters when we look at the denominators and we think, what is the least common denominator between 2 and 3? The answer is 6. All the while, you are watching and writing down the notes. I don't want you doing this on your own today. You are following along, writing down the notes. Now, in a fraction buster, you are going through and we're going to bust up these fractions by multiplying the numerator and dividing the denominator. 6 times 2 is 12. Divided by 3 is 4, and I still have the x. 6 times 4, but there is no denominator, so it's just 6 times 4 is 24. On my right-hand side, 6 times 1 is 6, divided by the denominator, 2. 6 divided by 2 is 3x. One more, 6 times 9 is 54. There's no denominator, so I have 54. I want you to notice that the fraction has been busted. It's gone. Okay? That's the benefit of knowing how to do a fraction buster. Now my equation looks so much prettier. Okay? I need to do my first legal move. My first legal move that I'm going to do is going to be a side-side flip. I'm going to flip this 3x over here I'm going to side flip this 24 over here. And I am going to be left with 1x equals 30. 30 what's? Do you remember what real world quantity we're talking about? We're talking days. 30 days. Okay? Now, step 1, when you want to know when two things are the same, you set them equal to one another. We did that. Step 2, solve for x. We did that. Step 3, check for y. So here we go. I am going to rewrite my equation 2/3, but I am not going to write x, the variable. Plus 4 equals 1/2, not x, plus 9. And what I'm going to do is I'm going to take my answer, 30. I'm going to go ahead and make this a fraction just so that, when you're multiplying fractions, I like to keep everybody with a numerator and denominator. And let's go ahead and do the math. 2 times 30 is 60. 3 times 1 is 3. So I'm thinking 60 divided by 3. You don't have to write that down. 60 divided by 3 is 20. Notice another way that you could have done that math is you could have divided first. If you notice that 30 divided by 3 is 10, and then done the multiplication, that thought that you had, 30 divided by 3, that's called cross-canceling, and you would have still ended up with 20. Let's see, and that 4 doesn't change. 20 plus 4, 24. On plant B side, 1 times 30, 2 times 1. Those are 30, and on the denominator 2. So what is 30 divided by 2? I get 15 and 9. 15 and 9 make 24. I want you to notice in my check, we're going to write a sentence, okay? In 30 days, write the sentence underneath this whole thing. In 30 days, comma, both plant A and B will have 24 inches tall. This was the purpose of the entire lesson. Okay? You are going to have to come up with rules from language arts math. You're going to have to turn it into math symbols. You're going to have to know, if I want two things to be equal, I set them equal. I solve for x. I bring that back and I check for y. Now, I want you to notice some people are going to be tempted to go back to this equation to check. That's a great idea. But this equation is 6 times larger. You would get an answer 6 times too big. And so you have to be careful when you check. You need to go back to the original. I know it has fractions. I know that's annoying. But that is the process for today. Not the only problem. Next problem. 5-53. Felipe applied for a job. The application process required him to take a test of his math skills. I like this occupation. One problem on the test was a system of equations, but one of the equations was not in y equals mx plus b form. The two equations are shown below. Okay, so I have one workable, one not workable. So what we need to do, once again, is we need to do a little work. Now, what we need to do with this problem is we need to solve for y. Y equals mx plus b. So step 1. Do me a favor, just watch, don't copy. Just watch, don't copy. Let's see, I need to side flip, and then I need to divide. This is 2y equals. Then I need to divide everything, and that is going to give me negative 3 over 2x plus 9 over 2. Notice I left my fractions improper. Some people think improper in mathematics is bad. It's not bad, it's just improper. And sometimes it is more efficient to work with them like this than it is otherwise. So I now have y equals, and because I have y equals, I now have two workable equations. What I want you to do at this point is to pause the video, copy this down on the left-hand side of 5-53 so that we can go ahead and begin working. Pause the video, copy it now. All right. I want you to notice, once again, we have a fraction buster. I want you to notice that I have a problem with a denominator of 5 and a denominator of 2. Okay? So I'm going to go ahead and multiply this by the common denominator. 5 and 2, 5 times 2 is 10. Now, I'm going to ask you to multiply each term. Multiply the numerator, divide by the denominator, and see what you get. Pause the video now. Okay, welcome back. That should have been a great opportunity to practice fraction busters. Now, I know fraction busters are hard. I know they are confusing. No, it's not on the Chapter 5 test, but it will be on the Chapter 6 test. So it's good practice right now. 10 times 2 is 20, divided by 5 is 4x. 10 times 5, negative 5 is negative 50. 10 times negative 3, negative 30, divided by 2 is negative 15x. And 10 times 9 is 90, divided by 2 is 45. Now, what I want you to do, side, flip, regroup, x equals. Pause the video, follow those 3 steps. You might want a calculator. Pause now. Okay, you should have side, flip, 19x. Side, flip, 95. Okay, that's sending this over there and this over here. Divide, probably with a calculator, x equals 5. Step 1, when you want to know when things are the same, set them equal. Step 2, solve for x. Step 3, check for y. Notice I have the original equations. So I'm going to go through it. I'm going to plug in the value of 5. Let's go ahead and rewrite these. 2/5 times minus 5. And I need to use this. We need to make sure that we use the original, but I need it to be y equals. So you can see that I wrote that in. Go ahead and copy that in your notebook, kind of on the right-hand side of 53, so that we can take care of that. So I'm going to plug in my answer, 5 over 1. 5 over 1. Notice anytime we're checking our solution, in this case for y, we want to use our answer. Okay, this is called evaluating an expression. Now I'm going to go ahead and multiply these out. Multiply straight across and divide by the top divided by the bottom. So 2 times 5 is 10. 5 times 1 is 5. So 10 divided by 5 is 2. Notice, if you cross-canceled first, you'd be left with 2. 2 minus 5, not 5 take away 2, but 2 take away 5 is negative 3. On my right-hand side, we have 5 times 3 is 15. So negative 3 times 5 is negative 15. 2 times 1 is 2. So I have negative 15 over 2. That's going to be negative 7.5. Notice I'm finally getting it out of that improper fraction. And then I have plus 9.5, or 9 divided by 2 is 4.5. So what is 7.5 take away 4.5? Mr. McCoy, that says plus. No, this says take away. So we're noticing positive, negative, I take away, and I notice 7.5 take away 4.5 is 3 and you carry the sign of the bigger one. So yes, -3 equals -3. My answer here is 5, -3. This isn't a real world problem, so I don't know what we're talking about. If it were the, I don't even have a good example because of the negative, okay? The x value, your answer is 5, your y value is 3. If this were on a graph, it would cross at 5, -3. And this is the full problem. Let me tell you guys, this is a ton of work. It is super hard, and it's going to take us time to get used to how to solve these problems. Hopefully you have that all written down. If not, pause the video and make sure that you finish copying our answer. Make sure that you note our answer here is 5, -3. Now our final problem, you guys have room to work, but you don't need to do that. All you need to do is watch and listen, okay? Solving by inspection is solved by looking. That's what it means. Inspection means looking. You're going to get to a point in your math career where you are going to be able to look at a problem like this, notice a relationship, and you're going to be able to solve it. Okay? On the weekends, I climb trees. I can just look at a tree and know what the problem is and know how to fix it. People who are mechanics, they see a problem, they hear a problem, they can solve it by inspecting, investigating, and they know how to solve it. These are two problems that you can solve by inspection, because if you notice this relationship, you are going to learn, oh, these have the same growth, but a different intercept, which means they're parallel lines. And so if you have two parallel lines and you ask yourself, when do these lines cross? Well, parallel lines don't cross. And because these lines are parallel lines, they never cross. Just by looking at the relationship, you know that there is no solution without doing any math. Okay? Now, I want you to know, on our last problem, I notice once again that there's another relationship. I notice right here, each of these numbers are 2 times bigger. So, Mr. McCoy, what does that matter? Well, it's like asking, when you compare the fraction 2/4 and, 4/8, or even 50/100, what do you notice about all of these fractions? They're all different, but they're also all equal. They're all the same. And when you simplify these fractions, they all end up to be 1/2. Different numbers, same value. The same thing is happening here. These are the exact same equation. This one is just 2 times bigger. It's like an equivalent fraction that's 2 times bigger. What does that mean, Mr. McCoy? Well, that tells me that these lines, even though they have different numbers, they have the same value. So 2 lines that have the same value, well, when do these lines cross? Well, if they're 2 lines with the same value, they're always crossing. They have all solutions. And I don't expect you to be able to do that right now on your own. Eventually, we are going to get to the place where you can look at this and you'll be like, oh, no solution, or all solution based on relationships. As you develop your skills and your expertise, you'll be able to just look at something and know how to solve it. And that's a really good feeling. Thanks for coming today to the final lesson in Chapter 5. You are going to see additional videos for our Chapter 5 practice test, because there are some difficult skills from chapters 1, 2, 3, 4, 5 that you have to be able to do finishing Chapter 5. No excuse. So, stay tuned and good luck.